All right. So, a very good evening, good afternoon, good morning to all the respected viewers who are watching this video of mine. I welcome you back again to one video, which is continuation of my previous videos regarding Python. So here, what we are talking about is Python operator, which is a very distinctively important and commonly used topic in Python programming language. So let's go to the PowerPoint presentation. So, water operator. Now, operators are symbols in Python that are used to perform operations on variables and values. They act as instructions that tell Python to carry out tasks such as arithmetic calculations, logical comparisons, assigning values, working with bits, or checking membership and identity. So these are all different types of operators. We'll go to details 2 minutes later. So without operators, programming would be difficult as they simplify mathematical, logical, and making tasks. So basically, operators are what they are special symbols that Python uses to perform operations on different variables and values. They are like an instruction that tell Python to carry out different tasks. All right, and that those tasks can be arithmetic, even logical comparisons, even assigning values, even working with bits. Okay, and checking for the membership, identity, all those things. Now, for example, we can see that operator is used to add two numbers, whereas double equal to sign is used to compare equality between any two variables or any two number or anything else. And inside this bit I intentionally has been made. This in is used to check whether the value exists inside a sequence. I know the clarity is not happening right now, but as we go into the details and hands-on practice, it will be absolutely clear. There are types of operators. So arithmetic operators, here are a few small comparative operator or inside the bracket, logical operator and or not, alignment operator, bitwise operators, members operators, identity operators. Let's start with arithmetic operator. Arithmetic operator is used to perform mathematical operations. Now, what are the examples? Example include addition, subtraction, multiplication, division, modulus, floor modulus, exponentiation, comparison operators. Now, used to compare two values and return either the true or false. Examples include if it's double equal to, that means it equals to something which is on the left hand side to the right hand side. Exclamatory mark then equal to, that is not equal to, that means what it is in LHS is not equal to in RHS. Greater than means greater than sign, less than same, greater than equals to, less than equals to. So these are all comparison operators used in different symbol as text. Now logical operators. Logical operators are used to combine conditional statements. They are and or not, for example, and returns that the value is true if both conditions are considered to be positive or true, or returns if either of the condition is true, and not reverses the truth value. Interesting one, we'll see all those things. Assignment operators used to assign values to variables. The most basic is equal to, which is simple assignment, but Python also supports compound assignments like plus equal to, which means plus and equal to add and assign. Minus equal to means subtract and assign. Multiply equal to means multiply and assign, and so on. By operators, these work on binary representation of integers. Examples are and, which is bitwise and, this symbol vertical which means bitwise or, this means XOR, this means not, this is left shift, this is right shift, and they are useful in low level programming, for example, cryptography and performance optimization. Then what we have membership operators used to test whether a value exists within a sequence like list, string, tuple. All these are a part of the syllabus which will come afterwards when we go into further more videos in more details. Python. The keywords are in returns true if the values are present, and if it is not true it returns false. Identity of operators used to compare the memory locations of objects. The operators are is returns true if two variables point to the same object, and is not if it returns true if they point to different objects. The syntax and application. The syntax of operators depends on the type. For example, arithmetic operators are used between numbers a plus b. Comparison operators are used by decision making statements like if, else, elif. Logical operators, if something is greater than something and something is greater than something else, then print both conditions are true. So these are logical operators. Assessment operators is a plus equal to 3, which means a equals to a plus 3. That means the value of a now changes to a plus 3. Syntax and application. Bitwise operators are applied on binary numbers x equal to 5 and 3. We'll go into all these things in details. Membership operators helps in searching if 2 is present within this set of 1, 2 and 3, print found. Then if it is not there, then it will print not found. That will be given in the decision making statement of else. Identity operators print if a is b, print same object. So those applications include mathematical calculations, conditional logic, iteration control, search operations in sequence, data structure comparisons, and even performance in critical bit level manipulation. So now I quickly move on to the hands-on part where it has been given that write a Python program to show the application of various operators. So let me take a bit of time to share the Google Colab. I don't know why am I not being able to find it. I think I'm visible right now. You can see that I'm currently present in the Google Colab interface where I have named the file as Python operators.ipynb, which is the dot file name of Python. So let us start the program. Write a Python program to show the function of various operators. All right, so Let us start with what? Let us start with comparison operators. So comparison operators. So A equal to, I put a value of say 10. B equal to, I put a value of 20. Then I go for print. Inside that I write A equal to B colon. Then I come out of the string liberal, give comma, then I put the operator A equal to B. Okay, so this is one part. Then print again inside string liberal A exclamatory mark colon, come out of the string liberal A greater than B colon, out of string liberal the same thing. Now I need to make it less. Now the meaning of these symbols are, if the LHS is same as the instruction given in between, then it will show true, otherwise it will show false. Then what? Then again greater than equal to, less than equal to. So this is greater than equal to, and this is less than equal to. All right, so till here I hope it's clear. Let us find out the output. The starting of the program takes a bit of time. So you see, okay, I missed out a space here. It looks good. You see, A equal to B, it's not true because the value of A is 10 and B is 20. So it gives out to be false. A not equal to B, which is actually true. So it gives out true. A greater than B, which is false because 10 is less than 20. So it gives false. A is less than B, that is true. A is greater than equal to B, which is false. It is not equal to. A is less than equal to B, that is true because A is lesser than B. Okay, so these are the outputs of comparison operators. Let's go for the other codes. which is for logical operators. See, I've put a value of x as true and y as false. So these are binary statements. Next, what I've done, I go for print, then inside the string liberal, I show as x and y colon. Then I come out, give comma, and write x and y. Alright, so this is one. Let me just copy and change the intermediate syntax, which is or. Here also or. Again, same change, not x, not x. Let us find out the outputs. So you see, x and y, obviously, if one is 0 and another is 1, so here, oh sorry, if one is true and another is false, the summation or the addition of x and y produces false. If either of the cases, if it is, then it produces true and not x, as x is true, so it gives out the result to be false. I hope it is clear. X is true, y is false. So all the time the false statement or the false values is dominating one. So as x and y you have given, so false is the output, or is the other one. That means either of the cases, now true is dominating, so it is showing true, and not x means the either case of x which is given as true, that will be false. So it is not x, so it is false. Now if I change it, not y, you see, as y is false, so if it is not y, so it gives true. I hope this logical operators is a bit clear to you. Let us move on to assignment operators. This is just an introductory class where I'm just introducing the Python operators to all of you. People need not to worry. We will have separate hands-on classes on Python programming where in details we will go through how to deal with different operators in other programs also. So this is assignment operators, num equal to 5. Now let me put a variable as num, that means number. Now number plus equal to number plus 3. We can write this also. We can also write this one. We should make an habit or a practice of writing in this way. Now I just write it beside that num plus equal to 3 means num equal to num plus 3. Now let us check one thing. Does the value really gets changed? So after plus equal to 3 colon coming out of string liberal num. I expect it to show 8, 5 plus 3. Now num, now I'm changing the value again. Minus equal to 2. So let me write the meaning. Num minus equal to 2 means num equals to num minus 2. So if it is 8, it happens to be 6 right now. So after num equals to 2, what should be the output? It should be 6. So let us check. You see, after plus equal to 3, the value is 8. After minus equal to 2, the value is 6. So this is assignment operator. Now let us go to the bitwise operator. A new topic or a kind of new thing to every one of us. P equal to, let me put a value of 5. Q, let me put a value of say 3. Print P ampersand Q equal to P ampersand Q. Now it has a meaning. Let me write the meaning. Then the scenario becomes a bit clear more. What is the meaning of this bitwise? And 5. It is having a value of 0, 1, 0, 1. Okay, this is the bitwise representation of digit 5. Now if I put and 3, which 3 is also having a bitwise representation of 0, 0, 1, 1. Then and means in summation case, it means all the digits from the right hand side to the left hand side will undergo a comparison of the first digit of this one and this one, as both of them are 1. So thus it will have an output of 1. Now next digit, this is 0, this is 1. So it is not having both of them 1, so it will be 0. Next again this digit 1 and this is 0. So again one of them is 0, so it has to be 0. And here both of them are 0, this one and this one, so it will also be 0. So thus the output is 0, 0, 1, so it is 1. Next, print P, this symbol, this vertical line present above enter in keyboard. It represents what? Or. So bitwise OR means either of the values. It will produce 1 when either of the digits in each decimal place is being 1. So this first one is 1 and this is 1. So it is giving 1. Next, this one is 0. This one is 1. So as one of them is 1, so this is also 1. Then again, this one is 1, this one is 0. As one of them is 1, so it will give 1, and both of them are 0, so the last digit will be 0. Now, this is a binary number which is actually 7 in terms of the real numbers. Then print P I'm not finding the symbol. Yes. So here Q. For this symbol, we have to press Shift numeric 6. Then coming out of string liberal again. This represents XOR. The difference is when both of the cases are 1 here and here, it will produce the opposite, which is 0. And when either of them are 1, it will produce 1. So thus, it produces 0, 1, 1, 0. So which is 6 real number. I hope you understood the function of XOR. When either of them, when comparison is happening between two operators, is one of the digits, either of them is 1 or another one is 0, so it will consider one value. But if both of them are 1, it will consider as 0. But if both of them are 0, it will consider 0. It will not convert to 1. That is a function of XOR. The next one is bitwise NOT. Print this is an interesting symbol. Yeah, you might feel that you are also hovering around in the keyboard to find out this symbol. This symbol is present above tab on the left hand side. Coming out of string liberal, then pressing this wavy symbol, and then it gives bitwise NOT. Bitwise NOT, where this meaning of this 5 is actually equal to minus of 5 plus 1. which is nothing but equal to minus of 6. So thus it inverts all the bits. Okay, then next one is print left shift p less less than sign p 1. Let me write both of them first. This is left shift. Shifts bit of 5 left by 1. It means if it was 0 0 1 0 1, it will be 0 1 0 1 0. This part is getting shifted to the left hand side. You see it coming, it comes over here. Now what will happen to the right shift? It is just the opposite. It shifts to the right by 1. If it was something like this, it will become okay. So these are the cases that we have. All right. So I was very sorry. I put an extra 0 over here. That's why this problem is happening. Acha, the meaning of 1010 is actually real number 10, and this is having the real number 2. Now let's quickly find out. You see, P and Q is 1. This is the real number 1, and this P vertical line Q, it gives 7. And P, this kind of a power symbol or something like that, gives the value of 6, which is of 0 1 1 0. And this wavy P, it gives plus minus 6, and it gets shifted on left hand side by 1 decimal place. Decimal place means unit, or ones or tens or hundred, those things. Then becomes 10. Oh, very sorry, I did something wrong. Yes, I missed out this one. It should be greater than 1, and this should be greater than 1. Yeah, let's go for it again. Yes, you see, it gives to be 2. So thus This is the output for bitwise operator. What more are we left out with? Membership operators. Let us put very quickly a variable, say x, and let's put a set which is having the value of 1 comma 2 comma 3 comma 4 comma 5. It can be anything. I'm just putting these values, which is a list. It creates a list. This is a list. What is list? All these details will come to a separate segment. Creating a list of with 5 elements, 1 to 5. Next, print, say 3 in x colon, coming out 3 in x. That means it gives true value if 3 is present in x. Print 10 not in 10 not in x. It gives what? It gives also gives true value if 10 is not present in x. So let's go for the output. Oh, very sorry. 2 times print I have put. That is why I'm thinking, what error is this? So you see 3 in x is true and 10 not in x is also true. Now if I put say 3 not in x, so it has to be false. See, it's false. Let me put 10 again. Alright, so we are left out with the last one, which is identity operators. Now you tell yourself these are interesting but very small topics which has a importance. Let me create a list M having values of 1 to 3. Let me put another value of N also having same values 1, 2 and 3. Now let me have a variable O equal to M. Now let us check. So I'm not writing the details. List M. This is list N with same value, but as we have provided a separate variable, it will have a separate memory location. And O is doing what? O is pointing out to the same memory location as M. O points out to the same memory location as M. Now let us go for the print. M is N. Now I question you, is it true? Now you'll say yes, but it's not true because the memory location of M is not N. So it has to be false. Values of M and N are same. Like I can have a bucket of 3 apples, you can also have a bucket of 3 apples. It does not mean that both the buckets are having identical apples. M is N. Now checks what? Checks if M and N refers to the same object. Now it has to be false. Now next one is if M is O or not. Now again I question all of you. You tell me, is it false or true? It is true because you see O points to the same memory location as M. So checks if M and N, sorry, M and O refers to the same object. Okay, so this is true. Last, again, let us go for is not. Is not. So M is not N. Now obviously M is not N, so it has to be true. So checks if M and N refers to the different objects. Now this has to be true. Now let us check the output. M is N, which is false. M is O, it is true. M is not N, that is true. So again, I recapitulated. These are the comparison operators where you have compared different small arithmetical symbols, logical operators where binary statements have been compared, assignment operators where we have shown the usage of this variables which gets changed by itself, and again we print it, then again it gets changed, again we reprint it. Bitwise operators, this is an interesting and new thing where we have discussed about the functionality of and, or, XOR, not, all these things, left shift, right shift. And membership operator, here we have created a list and we have checked that if a particular value is present inside the list or not. If it is present, it gives true, otherwise it gives false. Then identity operators, again two lists, and we have checked the both lists are, though having same elements, but they are identically not same because they are not stored in the same memory location. So it will not represent that both the variables are same. It is different. So it gives false value. But whenever we are assigning a variable to another predefined variable, then both the variables are same, located in the same memory location. So thus it is giving true value. All right. So this is a very short representation of hands-on programming in Python, where we had discussed about programs, Python program to show the application of various operators. So I end this video session over here. Next, what we will be discussing in our next videos, we'll be discussing regarding the strings. Very interesting one. Introduction to strings, concatenation, repetition, indexing, slicing. Okay, we will go to that in our next video. Till then, I wish you a great day ahead and see you again back in my next video. Till then, bye bye. Have a great day. Thank you so much.